Hey everyone, and welcome to this explainer. Okay, so today we're diving into something absolutely mind-blowing. We are setting the stage for a truly incredible, completely hypothetical journey through space. We're going to be unpacking a really fascinating breakdown from the Wishma Lokaya channel about one of the greatest, most stubborn mysteries in modern physics, faster-than-light travel. We've taken their analysis and distilled it down to help you wrap your head around exactly what physics says would happen if we actually tried to break the universe's ultimate rule. So if you're someone who loves to geek out on how the cosmos fundamentally operates, you are definitely in the right place.
Right off the bat, picture this. Imagine you're stepping into a highly advanced, futuristic spaceship. You buckle in, you fire up the engines, and you decide you're going to attempt to absolutely shatter the universe's ultimate speed barrier. So what actually happens? Do you just keep accelerating forever, kind of like a sports car on a wide-open, empty highway? Or does the very fabric of reality itself step in and pull the emergency brake? Well, to figure that out, we first really need to understand the absolute boundaries set by nature.
And that brings us to Section 1, the ultimate speed limit. Let's establish the baseline for this wild cosmic journey.
Now, we actually stumbled across a pretty hilarious linguistic quirk in the source material when looking at this speed limit. When exploring this strict boundary of the universe, which is, roughly 300,000 kilometers per second, the source refers to this majestic, completely unfathomable cosmic absolute as allo kavag, which means the speed of light. But thanks to some delightful, wonderfully garbled translation anomalies in the original text, this was contrasted with the phrase aluya tamatarvegi, which literally translates to the speed of a potato or tomato. Honestly, it's hilarious, but it brilliantly illustrates our starting point. On one hand, you have the mundane, everyday speeds of the stuff we interact with here on Earth, our metaphorical tumbling potato, and on the other, you have allo kavag, a speed so extreme that simply getting close to it fundamentally breaks our everyday understanding of physics. We are basically trying to graduate from the tomato to the photon.
So, what's the big physical roadblock standing in our way? Let's move right into Section 2, the infinite mass problem.
Okay, so the crucial mind-bending point here is that in our universe, cause and effects take on a very, very strange reality when you really hit the gas pedal in deep space. Let's walk through the sequence. Step 1. Your spaceship's speed increases significantly. You're cruising. You're going way faster than any human ever has. But here is exactly where the universe pushes back. Step 2. Your mass multiplies. In the source material, this is described as going duguna, which basically means to multiply or become twofold. See, your mass doesn't just stay the same. The faster you move, the heavier your spaceship literally becomes. It gets incredibly dense. And because you're getting heavier, you suddenly need exponentially more energy just to keep accelerating, which leads us straight into a brick wall at Step 3, approaching the infinite.
And that brings us face to face with a daunting, inescapable reality, anancha, infinity. As your spaceship inches closer and closer to the speed of light, that multiplying mass we were just talking about, it doesn't just stop at some really big number. It approaches anancha, complete, crushing, infinite mass. And why does this matter so much? Well, think about it. To move an object that has infinite mass, you would need an infinite amount of energy. And since infinite energy just doesn't exist anywhere in our universe, you physically cannot accelerate a mass-bearing object to the speed of light. Period. The universe essentially puts up an unbreakable mathematical wall, no way around it.
But mass isn't the only thing that goes completely haywire here. Let's look at Section 3, experiencing time dilation. We're moving from the physical limits of mass to the psychological and physical bending of reality itself.
This introduces us to the phenomenon of kal prasar, where time fundamentally stops acting normal and just stretches right out. Let's say you were somehow able to survive that infinite mass buildup and actually travel near the speed of light. Well, your experience of time literally warps. For you, sitting inside the cabin of your spaceship, time feels completely 100% normal. You drink your coffee, you read a book, your watch ticks exactly like it always has. But compared to everyone back on Earth, your time is slowing down to an absolute crawl. This is kal prasar. You could travel for what feels like just a few years to you, but when you finally turn around and return home, decades, centuries, or even millennia might have passed for the rest of humanity. You literally become a time traveler, completely out of sync with the reality you left behind.
I know, all of this sounds like wild, made-up science fiction, right? Well, that leads us to Section 4, the final theoretical reality, where we bring these abstract concepts back down to a foundational rule set.
We really have to remember that these insane, mind-bending effects, the infinite mass, the literal stretching of time, they aren't just random sci-fi guesses.
They are rooted in a very firm theoretical framework, referred to in the source text as a beta-atmic siddhanta, or a foundational theoretical principle. This siddhant strictly dictates our reality. You can think of it like the underlying operating system of the entire cosmos. It tells us that mass, speed, and time are not independent, static things that just ignore each other. No, they are deeply, intimately interconnected. When you push one of them to the absolute extreme, the others must compensate. The universe is a perfectly balanced equation, and this theory provides the rigid boundaries that keep everything in existence from just falling into total chaos.
Which leaves us with this final, thrilling thought. We've seen today that the universe has these built-in, absolute safeguards, like infinite mass and time dilation, that physically prevent us from crossing its ultimate speed limit. But if the cosmos is designed with such incredible, rigid barriers to keep us moving at a very specific pace, you really have to ask yourself, what other secrets is it hiding out there in the dark? What other fundamental, unbreakable rules are out there, just waiting for us to discover them? Keep that question in mind as you continue your own learning journey. Thank you so much for joining me for this explainer. And I really hope this structured look at the crazy physics of light speed has sparked your curiosity to go out and explore even more.